Okay,
Hi,
so
Rémi.
everyone is here. Perfect. So welcome everyone. Welcome to this new webinar. I'm very happy to be here today with our friends of Artifakt. I'm Kevin, country manager of France for Sylius, and hello from Italy. Someone is saying, okay, hello everyone. So I'm Kevin, country manager of France at Sylius, and first of all, maybe let's just introduce our guest today, and maybe we'll start with Djalal.
Hello, everybody. I'm Djalal, developer relations at Artifakt, and I'm very happy today to share with you all I've been learning about Docker for the past 7 years. Also, so very excited. Thank you, Kevin, for the opportunity.
You're welcome. Thank you, Djalal. And Rémi, if you want to introduce yourself.
Okay, hi everyone, I'm Rémi. I've been product manager at Artifakt for a few months now, and same as Jalal, really happy to be here. Thank you very much, Kevin, for the invitation.
Thank you, Remy, and I hope you guys like the French accent because you will have a lot of French accent today. And but we are very proud of our French accent. So yep, if we are all set and all ready, just for information, uh, today's webinar will be split in 4 parts. First one is the introduction that we are doing right now. Then we'll go with Jalal around the good practices of development with Docker, and then Remy will talk to us with and explain us why the PaaS is the new developer's best friend. And we will finish with some question and answers. Please, guys, feel free to ask your question all along the webinar if you have some. And yep, maybe we should just start and let's go with Jalal with the good practices of development with Docker.
Yeah, thank you, Kevin.
You're
So
welcome.
yes, first things first. What are we talking about when you say Docker? So Docker is three things. Docker, Docker, Docker. Docker is first a startup. So when your name turns into an action or a common name, it's a good sign that you made history. So today we Dockerize code and we run Docker things and so on and so forth. So second thing. It's also an ecosystem. So since the startup came up with these concepts as universal building blocks that are now available in most cloud providers, public or private, we now shop for Docker registries and we deploy with Docker Compose using volumes and orchestrators. So all these terms had little visibility until the Docker wave hit. So you may have heard about namespaces, control groups, copy on write. So they were there. They were just really hidden inside the Linux kernel. So that's what Docker did. And third thing, Docker is also a lot of tooling. So you can play with all these primitives. And since 2014, the Docker command line has matured into, that's my opinion, the most versatile tool. And it can talk now with any container-based platform, you name it. So here's what we name about Docker. So that's an introduction. Now let's talk about pitches for your managers and decision makers. So on the following table, you can see that we changed dimensions when it comes to write software and maintain software. So before you had this monolith with long development cycles on a unique environment, scaling very slowly or very risky. So now it's really accelerating toward a decoupled architecture with many short development cycles and many various environment where you deploy, test, and validate. And scaling also is going really fast and also unpredictable. So these are many challenges. And it's clear now why Docker made it and succeeded because they made this genius analogy. Let me explain. So this multimodal transport by containers, this works very well. Everything starts with like 10, 15 years ago with global transport and logistics. That's globalization. So frontiers opened up and all sort of commerce and domain actors would quickly, they had this challenge. How do we safely and securely transfer any kind of goods using any kind of transport? So for this, experts agreed on the standard and the process and began shipping containers like you can see on the road or on ships. So these are very detailed specs. They are standard of how to open them, how to hang them, how big it can be, and so much and so forth. So guess what? In our own software ecosystem, we face the same challenge. So for our own goods, that means software, data, and these are the goods, the apps, and the middleware, the front end, the back end, etc. So, and we are also deploying lots of environments, bare metal, public cloud, VMs, and your laptops, etc. So that's how the container was born. This term, it was coined like this. It's a very genius move, in my opinion. So the concept, again, we're already in the Linux kernel for years. It's only a practical term, making it easy to grasp. So Docker succeeded in creating those tools and abstractions and making the complex very easy and creating a whole new ecosystem. Now these abstractions, now today, 2022, they are the de facto standard. These are shared by our industry, and that's what managers and decision makers need to know. Okay, so let's now take a look and deeper look into the more technical pitch. So I chose 6 main promises of Docker for developers and system administrators. You can find more, but these are, in my view, the most important. With Docker, we can escape dependency hell. We can easily implement a CI/CD. We can easily make developers work with ops, and we have also this wonderful service discovery out of the box. We also make onboarding contributors very easy, and we do what the holy grail of developers and system administrators is to keep the same artifact from development to production. So let me take it point by point. Now it's finished. The time that we were saying it worked on my workstation, it worked on my laptop. Now this time is finished because Docker now allows us to express in a single little file, the Docker file, all the dependencies of your application. And even better, if you put this file next to your code in the Git repository, this is now shared with everyone, every developer, past, future, or every colleague and coworker. So we are able to document, script, and share this knowledge that was previously it was scattered. It was between teams and in documentation, Excel files, and very difficult to exploit quickly. So that's very good perk for developers. So second point is, how do I implement a CI/CD? Easy. Just I put it right on the screen. Once you git commit and git push, you can test urgent changes, deploy a major update, test a switch from Debian to Alpine, detect a regression in a previous image. So this is a really mature pipeline that you can enable with any software pipeline in the market. Third perk is that now developers are working with ops together. So Docker is now, the Docker file is now the common interface contract between dev and ops. This is due to this new tendency, this new trend that system admins have to script and have to code even their environment. Yeah, I don't know if you heard about infrastructure as code. That's it. So the developers, what they do, they will put their dependencies there in the Docker file along with the application code. And at the same time, administrators, sysadmins, they will contribute and they will augment and enrich the final Docker image with various binaries, model specifics to their scope, security, etc. So on certain points, devs and ops will also go further and discuss and negotiate on such thing that as observability and health checks. So that's really cool. That's a really nice example, instance of how we can implement DevOps principles and agile principles. Moving on the Docker system that is also widely native cloud. So we have now separated the plumbing from the business logic. So like you see on the little real code, real world code that I put, this sample, you cannot see any hard-coded IP addresses, right? You cannot, you don't see any FQDNs or domain names, okay? So this is really working in the Docker ecosystem. So you just stick to one service name, you name your service, and the container magic does the rest. So container magic, that means this embedded DNS, dynamic DNS that is embedded into each container. These will do the plumbing. We don't, as developers, need to do this anymore. So that's very nifty. Also, if you one day have to onboard new colleagues in less than a week, now it's okay. Remember previously when you did it in 1 month or several weeks? So now all you have to do is, I start the week, give me my access and laptop, my credentials, and I can launch a test version of your app in 2 commands. So whether you have a monolith, you have a 3-tier architecture, or 20 microservices, each with their own database, it doesn't matter. It's always the same command. First command, you get the code with git clone. Second command, you run a full test version with Docker compose up. And third command, you have no command. You can start working and testing. So how neat is that? And finally, this is also the holy grail for release managers. You don't have any difference between development versions and production version. How is it possible? So in practice, thanks to Docker and containerization, it's now trivial to guarantee that the binary tested in the different stages is the same as the one that will go into production. So this is what we mean in the 12-factor app principles. See, when in chapter 10, when they say keep production, pre-production, and development as identical as possible. That's the real thing. That's how we do it with Docker. And previously, believe me, that was very hard. So here are the 6 promises, very quick, for us developers and admin. So now, as promised, let's see how it applies on a day-to-day basis. So it's 3-step workflow. First step, your local environment. So how to approach Docker. So I chose these 3 daily pillars as a developer. So let's see. First pillar, you have to install Docker. Of course, it's free. It's on Windows, Mac, and Linux. So we will have 3 things. You will have the Docker server, which is the engine, a command line, the Docker, and also another CLI called Docker Compose. So under the hood, there are many more components, many more. So these components will talk with the kernel and everything, namespaces and control groups and copyright, etc. But you don't have to deal with the complexity. So again, container technology has been around for decades, but it was so complex. So now Docker just made it auto-magic. Second pillar, the Docker file. This is the artifact, this is text file that you sometimes make it very short, sometimes very long. It depends. You can have up to 128 instructions here, but you don't have to learn like a new language. It's really down to 5 to 13 keywords, really simple grammar. Okay, so I've put them in bold, and it's like a recipe. You just script your install process, and it's predictable, and it's everything. Every now and then, every build makes it reproducible. And third pillar, when you're working on your local environment, the Docker Compose. So it's another small file. It's not text, pure text. It's YAML this time, and really, it's it will express your entire stack. I mean, not only the code, but also the database it will write into, the files it will write into, the cache, and every other service that you need to work for the same app. So you write it once and you share it into the Git repository for the whole team. And with that, we can launch all these containers with a single command, Docker compose up. So the format and specification of Docker compose, it will expose these primitives. And these primitives, they help us to express the most complex architecture. So in very few lines, very succinct file, you can see, like in the example here, I put that I can build a network segmentation where you see the front network is accessible from the outside, yes, with a web server. But guess what? The back network is not accessible. It's really Redis and a worker working together alone, and no one can talk to them. And this is easily implemented with what you see as YAML code in the left. So that's quite powerful. So the complete complete specification of the compose file is a little heavier, but really not. It doesn't amount to the 100 of YAML line that you can write with Kubernetes and Terraform and other infrastructure as code. So it's very comfortable. Last slide for this local development. These are my own personal best practices based on years of experience. So how to recognize a good Docker file? You have 9 signs. I put them here on the left, from base image, from official sources, to don't use user root in your final image, and scanning and signing, etc., etc. So I will let you dive into this. You have our great blog post that made the front page of Hacker News a while ago, so you can go and dive into it. Docker Compose also is very powerful. In Docker Compose, you can express more, meaning that you can express CPU limits and memory limits. You can share resources. So you can also share data with volumes, okay, between containers. The Docker Docker Guinier, it's also the nifty file that everyone ignores, but you don't ignore the Docker ignore, because it can really speed your building times by 10 times. You just put 4 lines, the content of the Git ignore for starting, and it's really a great practice here. Also, what we do at scale at Artifakt, that we assess and we test images. We use handling, we use container structure test, which are 2 really interesting command line. And that also, you should think about testing not only your code, but also the artifact that is produced by Docker. Okay. So I have 2 minutes. Maybe I'm boring some of Rémi's time. Sorry. Just to say that the second step of your day-to-day work is also going to build and push. So when you see the classic DevOps collaboration, like build on the left and run on the right, you have this novelty brought by Docker. It's the ship stage, where we use the Docker registry as a secondary source of truth. The primary remaining, of course, the source code in Git. So with what we do inside this, is we scan the results, we sign the Docker image, we promote Docker images, and we make it available to other positions like QA and release management, etc., etc. Third thing is the big day, where you deploy in production. And with Docker, even with Docker, we face some unique challenges. So first one is the orchestration. How do we do at scale to automate upscale and downscale? And how do we start 3 containers of the API service and increase the number of services when traffic explodes, and deploy a new version without service interruption? That's orchestration. Also, we talk a lot of observability, because you have to keep an eye and an ear on production. So you have to save logs, you have to capture system metrics. And if you are doing microservices, you should consider grouping calls between containers and correlate them according to the entering request. So take a look at tracing, because this with containers and cloud native apps works very well. And finally, the most sensitive part is data management. So how do we administrate and make sure that data doesn't go away? Backup, restoration, optimism is very, very sensitive. Something that you cannot envision or implement in the Docker file or a Docker compose YAML. So this is all in production, this class of challenges, and we see that they are really more than the scope of developers of producing features. So in conclusion, you know that you see that the subject is very wide, but I have a good news that anytime you will spend with Docker right now for the next year or 2 years or 3 years, that will be an excellent return on investment on your career and your company, etc. So here we at Artifakt, we love Docker, we love open source. In fact, we have our own official Docker images on GitHub. So if you feel like contributing, you're welcome. And now I will hand it to Rémi. And thank you for your attention. If you have questions, you can put them in the chat.
Thank you very much, Djalal. And yes, Rémi, the stage is all yours.
Okay, thank you, Jalal. Very interesting topic indeed. What's left to talk about is that now that Docker has made everything so convenient, why would you ever do it on a PaaS and not yourself? The answer is very complicated, and that's what we're going to talk about in the next 20 minutes. So first of all, a bit of presentation because I need to talk to you about some of my biases. I'm 28, I'm from France. I've been PM at Artifakt for a few months now. Before that, I was systems administrator at Decathlon, which is a pretty well-known retail brand. I was working on the e-commerce websites. And then I was 3 years as a PO PM on a very big API at the French National Railway Company. And to my from various biases, I've been working with various SaaS companies like Splunk. And last disclaimer is about I'm very biased in favor of PaaSes in general because I used to do a job which is 100% replaced by Artifakt today. So you could say I'm a little biased about PaaS in general, but we'll see. So first of all, we're going to talk about what exactly is a PaaS and why should I use a PaaS. And the thing about PaaS is a lot of AAS stuff that you've been seeing over the last few years is sharing responsibility with your provider on different section of the stack that makes up a complete infrastructure. Like if you are on premises, you're basically responsible for everything from very basic hardware level stuff like networking to application installation, all the data that you have. And progressively, you go to infrastructure as a service, which is provided by a lot of providers today. Like, for example, Amazon Web Services. They take care of everything that is hardware related, but everything that's on top of it, like operating systems, middleware, runtimes, data, and applications, are still managed by you. Then next step is a platform as a service. Then it's everything that the PaaS, the AAS does, but on top of that, you also have everything that's operating system related, middlewares, and runtime. What a PaaS gives you is the ability to deploy some types of runtime, some applications. And finally, there's the ultimate do nothing solution, which is the software as a service, which takes care of everything. For example, Google Drive is storage as a service. You have nothing to manage. It's just somewhere you can put all your data in, and that's pretty much it. You have nothing to manage. And platform as a service is more akin to what we're doing currently at Artifakt. So why would you ever do it on the PaaS? Like I said before, I'm gonna give you a real use case of something that has happened to me before. Imagine being me, systems administrator, the evening before sales on traditional e-commerce website, whether it is Sylius, Magento, or whatever. It doesn't matter. It's always very stressful. So you're you're preparing everything and you're making sure everything's ready, and you want to anticipate that there is going to be a lot of additional load at the start of the sales period. So what you're going to do is you're going to add more servers to your infrastructure to take care of the additional load by adding a server to the server pool, and then maybe you have some checks to do with the infrastructure team to make sure that everything was made properly, that the server is properly configured, that is ready to be in the pool, that the code is properly deployed on it. Now that you have everything on the infrastructure side, you need to set up a maintenance page, maybe, to wait for the beginning of the sales. And then all you have left is your hands to pray, because there's nothing else you can do. So as predictable as it might happen that at minus +5 after opening, you get a big error on your website, and you don't know why. And it triggers the panic loop, which is you get tons of solicitations for everyone. You get people from sales, people from C-levels, people from technical side. Everyone tries to talk to you about what's currently happening. And all you can do is tell everyone that you're currently investigating, and that is a lot of time. Also, after that, you're going to obviously check all the different sources of logs to make sure that everything's working properly. And if you're not very lucky, you're going to check those by hand, and that takes a tremendous amount of time. If you have a centralized dashboard for it, it surely saves a lot of time, but that's still something that you need to figure out on your own. Then after that, after you assess the problem, you need to call whoever you need to call. It might be IT support, it might be the provider, the hosting provider, it might be your cloud teams, might be anyone. And then after you've done all that, you know what the problem is, you communicate to everyone, and you try to answer everyone on the phone, on Slack, or whatever. You try to fix it, or if you're not in charge, you just watch it go and watch people fix it while it's not working on a critical business day. So there's nothing much you can do, nothing more you can do. But yeah, some of you are gonna be like, yeah, sure, but that's a sysadmin problem, right? Yeah, of course, that specific case is a sysadmin problem, but there is another case where developers are directly impacted. You have the same error, but the question is different. The question is not about whether or not the load was actually managed properly by the servers, but maybe it's my own code. You pushed a version the day before or the week before, and that version was not stress tested, and yeah, it might happen that it's broken in production. So what do? You do like all the modern developers do. You take the branch, you get the master branch, you create a new hotfix branch, you develop a hotfix on it. When it's done, you try to deploy it on the QA platform, or you do the QA on the hotfix platform, and then on the dedicated environment, I wrote if you're lucky, because that's not the case of everyone. But here at Artifakt, we have individual platforms for literally everything. Every change has its own platform. Then after you've done testing it, probably even made it test by someone different, you deploy in production the change that you made. You push it to master, and then you deploy the master in prod, or production branch, or whatever you're using to deploy your production. So the fixing time is effectively the time that you're developing the fix, the time of the deploy on the QA platform, the QA itself that happens, and then the deploy in production. And in order to make that work, it has to work first try. Deployment has to work first try on both platforms, and your test environment should be as close to the production environment as possible, which might trigger things like this, where you try to push a fix and it worked on develop, but it doesn't work on production. So you see there's two different cases where whether or not you're doing some development work, or whether or not you're doing some infrastructure work, maybe you do both. But there's cases where it's just super tedious, and it's super easy to make a critical human mistake at any point in the process. So the PaaS has some answers for that, which are mainly auto maintenance. Some PaaS are able to automatically set up maintenance pages or stuff like that. You can have automatic scaling depending on what the load that is currently happening on the servers. You can have automatic scaling up and down. You can also have scheduled scaling, which means that the day before you can have some additional servers in the pool to warm up if there's things like cache to warm up before the opening. One that is super critical is build repeatability. It means that every time you build something, what comes out at the end is the exact same thing, because that's one thing to have one artifact for everything. But if your infrastructures are different between the different levels, pre-production, production, staging, and stuff like that, it might be that you have some differences that you cannot take into account when doing your development. So that's a very big advantage. You can create and duplicate things on the fly. That's also super practical, because in the case of a dedicated environment for testing, you just copy paste the production environment and here you go. There's some also added bonuses that are super difficult to do on traditional information systems, which are security related issues. I think that's web application firewall, DDoS attacks. Preventing your application against those is usually super tricky and involves also another provider, for example, Cloudflare, Akamai, whoever you want. Also, there's load balancing between the different servers. We talked about server pools, but that basically assumes that you have pools of servers, front web servers to receive traffic. And also logs platforms, which help you have one single place to look at when you have a fire in production. So what I can say is that it's pretty much all the tools you need to maintain and run a platform from dev to prod, which is super useful. So I'm going to be super biased again. We do it in Artifakt in that specific way. We just have something like number of front servers. You slide the slider to the point that you want, maybe 4 or 5 if you want to. There's a job to put some maintenance pages on, you do it. And then there's some pages that can help you access the different logs of your applications. So you can track errors way easier, way more easily than if you had to do it by hand. So then after that, if you need to fix something in production, that's exactly what I said before. You take the environment, you duplicate it, you change the branch, you build and deploy the branch that you want, the hotfix branch, and then boom, you have the exact copy of the production, but with the new code, just to see if it works. So that takes, in our personal experience, that takes about 10 minutes right now, but in the next few months, it might take something as little as maybe 2 or 3 minutes, actually. But yeah, you can always say to me, yeah, sure, I can do it myself. Yeah, sure, you can. But there's a lot of people that are very smart that are doing this already for you. So there's major differences between doing it the old way and doing it even with a SaaS product. The main thing that affects me as an ex-production engineer is the technical debt that is usually very out of control if you're doing anything in a traditional way. Even using infrastructure as code or very smart deployment practices, it's always your duty to be on par with the technical changes all over the platform. So that's usually the slowest one, because the slowest way of deploying, because you're doing everything by hand. Even if you take some off-the-shelf products to do so, it's your duty to stay on par with the rest of the technologies that you're using, so that everything still works. Also, it's a job for multiple people to do that. So it's usually people are telling you that it's super cheap to do it your own way, but it's cheap when you don't take into account the amount of people that you need to hire to make it work. Also, people might say that you'll be probably able to have the best customization possible if you do it in traditional way. That's true, actually. But will you have the time to do it so that you can benefit from it? It's not super clear for everyone. I mean, in my experience, in the last 2 companies I've been at, we certainly had no time to get the added bonuses of doing it ourselves. So you spend more time, you go slower, it's a bit more customizable, but you won't have the time to do it, or you need to hire even more people. So that's usually not a good budget practice. And in the PaaS versus SaaS, it's really how much do you want to have control over what you do? Because the SaaS does everything for you, but at the same time, it does everything for you so that you don't have to customize it. So if you have any need that is specific to your use case, there's a high chance that you won't be able to do it anyway. And in my opinion, it takes at least 2 people to manage properly a SaaS product, which is almost as much as a PaaS product, which I think 2 or 3 people are largely enough to do so. And usually also the SaaS is super, super expensive because they take away from you the responsibilities of everything. So it means that they can charge you for it, and that's what they do. So now that you know my opinion on PaaS products, just maybe a little shout out to the Sylius community. We recently deployed the 1.11 version, and that takes about 15 minutes from logging to operating platform to on Artifakt, just say 15 minutes. It's actually pretty insane for me, and it's soon to be even less than that. I'm currently testing it. It's working quite well, so we can expect in the next few months to be able to deploy pretty much everything in less than 5 minutes. Also, like I told you, horizontal vertical scaling makes super easy. So in terms of anticipating for big events, big e-commerce events, it's super interesting. We usually install templates, which means that you literally have nothing to do in order to make it work. And there's a lot of custom options after that if you ever need to modify the basic installation. The only downside is that currently we're not publicly available, so it probably means that you will probably need to talk with probably Kevin and then maybe with us for scheduling a demo. And we have very nice people that are going to take care of you if you do so. And that's it. That's pretty much it. Thank you everyone for coming. And that was a great time. I really hope that I convinced you that PaaS products are pretty good. And we also have a very strong bullet point on our side at Artifakt. It's just like Djalal showed you. Pretty much all we do, we try to make it as open as possible. So it means that the Artifakt repo is actually available to the public if you want to check it out. And that's it. Thank you.
Thank you very much, Rémi. Thank you very much, Djalal, as well. So thank you. And do we have any questions? I don't see any questions, but maybe it was it was clear, so clear, like crystal clear. So we don't have any question. But guys, if you have any question, just feel free to ask. We will wait, let's say like 1-2 minutes and see if you guys have questions. Okay, in the meantime, do you have anything to add on your side, Djalal, Rémi? I don't know, about some news, about some about Artifakt, about the projects going on your side?
I can talk a bit about it, but like I said, we're currently in private beta mode, but somewhere along the year, probably late this year, you will be able to test it, because we're currently rounding out the final details on the last things that we need to open it to the public. It's already pretty much enterprise grade. If you contact us, no worries. It's a very good product for enterprise. But right now there is no self-service, and that's going to come a bit later this year. That's currently what we're trying to work on right now. We're working a lot of the things that are critical to the product. But pretty interesting news. You can always follow them. We have a public. Our roadmap is actually public, and you can check it out at I think it's feedback.artifakt.io. You can check it out.
Okay. All right, and maybe we share the links and the deck. Sure. On the video on YouTube. Okay, so guys, we don't have any questions, so means that it's been very clear. So thank you very much, Djalal. Thank you very much, Rémi, for being here.
Thank you,
Romain, for your animation on the chat. And if you have any questions about Artifakt, maybe just feel free to ask and to contact me or Romain or anyone here. And that's it. Thank you very much, guys. Have a nice day, and see you soon.
Thank you. Have a nice day. Bye.
Bye, guys.
Bye.
Thanks.
Bye-bye.